your function, whatever it may be. That means I x minus iy by 2. So do you see? Or agar still if you are not satisfied, I'll write totally in terms of that x comma y tends to 1 comma 0, and it will be so it will be y by 2 comma x by 2. Now do you agree? Now if you want to solve this limit, क्या करते तुम लोग? If you want to solve this limit, xy tends to 1 0. Since either denominator में x and y नहीं है, तो there is no issue. You will directly substitute, correct? x की जगह पे 1, y की जगह पे 0. So this converts to 0, 1 by 2. But 0, 1 by 2 को हम लोग कैसे लिखते हैं? I by 2. This is what, correct? So that's why I was telling you to just revise your TyBsc, because ये जो complex number है that is same with your R2, जो R2 में किया है तुम लोग ने, continuity, differentiality, everything we are going to relate with this. Instead we will be doing of this form. That is quite easy for us to do. Okay, now my question is, can you prove by using epsilon delta definition this thing? Prove this by using epsilon delta definition quickly. Can you do that? Okay, how will you start with? Same thing. For given epsilon, here what we have to do, you have to find a delta, correct? Correct. So this is what you want to prove. So I'll start from here only. Consider mod of f of z minus I by 2. So what is your f of z? I z bar by 2. Yes, what about this? Yes, you already know the property of mod. Mod of z1 z2 is same as mod z1 mod z2. Is it? अरे बोलो भाई. This thing it will be same as mod of z minus 1 by 2 बोला तभी भी चलेगा. You just check. And since you have considered z minus 1 is less than delta, so this is less than delta by 2, and that is less than epsilon. What is delta you will choose? Choose your delta which is less than 2 epsilon, then that will work. Epsilon was given to us, correct? We need to find delta. So now I am having delta. What is the condition on my delta? Delta must be less than 2 epsilon. Okay, let me ask one more question. f of z equal to z upon z bar. Okay, so limit z tending to 0 z upon z bar. This is what you want to find out. Can you tell me, do you have any guess for this? क्या आएगा? Yes, anyone? Again, go back to SYBSC. If you want to find out this type of limit, then what will you do? Your function is same as x minus I, sorry, x plus iy upon x minus iy. Correct? Do you remember, if the limit of function exists, then it exists in all the direction, from all the direction. If you come from any side of z, your limit must exist. Z equal to 0 is here, correct? You can come from any side to this place. From every side, the limit must exist, correct? This was the definition. So I'll just do one thing. I'll come from this side and this side and check whether if limit is having the same value or not. Because if it is having different value, then what I will say, I'll say that limit does not exist, because it should go to a unique point. That is, now I just want to claim if it exists. I just got a hint कि ये exist नहीं होएगा. The question was prove that this is does not exist. Does not exist. I just asked you. Now how will you prove? Suppose if exists. If it did exist, then what? Then it exists in every direction. If you come from any direction, that means I have to write z equal to x comma y approach the origin in any manner. Now you will see something. But when I am taking a real part, that is z equal to x comma 0. See, purposely I am writing coordinates so that you relate it with your SYBSC. Suppose if I take z equal to x comma y, so since it is non-zero point and I am going towards 0, so what will be your limit then? F of z will be, at the place of x it will be as it is, and at the place of y it will be 0. So it goes to 1. Correct? In this case your z is this. And if I go from, this was real axis, if I go from imaginary axis, that is when z equal to 0 comma y, so limit z tending to 0 will be, क्या आएगा वो? Zero plus iy upon 0 minus iy, that is equal to -1. Correct? So once I am going from real axis I am getting 1, and once I am going from imaginary axis I am getting -1. So what is my conclusion? Since the limit is unique, we conclude that limit z tending to 0 f of z does not exist. Do you agree? You can go from any way. See, actually तुम्हें थोड़ा सा hint दूँ तो तुम लोग ने क्या किया था? You were putting y equal to mx, if you remember. You used to put y equal to mx, and your answer will be in terms of, if you put, your answer will be all it depends on your m. Correct? So you say that key if you put m ka value 1, 2, 3 something else, then you will get different values. So that's why the limit does not get. This is what I did here. I just take the simple one, that is take real axis and imaginary axis. That's it. You could have done by that method also. So just go back if you are still having some issues, then go back your SYBSC part and read that. Yeah. Okay. So let us do some theorem on limits. Theorem means there will be algebra of limit, and the first most important is, alright, theorem 1. Suppose f of z equal to u of x comma y plus I v of x comma y, and z equal to, where z equal to x plus y, and z naught equal to x naught plus I y naught, and w naught equal to u naught plus I v naught. Okay, then limit z tending to z naught f of z equal to w naught if and only if limit x comma y tending to x naught y naught of u of x comma y, that is equal to u naught, and limit x comma y tending to x naught y naught of v of x comma y, that is equal to v naught. The first question, ऐसा तुम लोग ने थ्योरम देखा है क्या in your SYBSC? Or do you recall something similar theorem in your SYBSC? Anybody? If I say something like coordinate, yeah, something, say x and y and sequence के टर्म में मैं बताता हूँ. It converts to x comma y if and only if x n converts to x and y n converts to y. Do you remember this type of proof? Same it was for functions. I just give you example. Do you remember? When do we say this sequence converts to this? When each of the coordinate converts to that, and similarly. So this is what here we want to prove. I'll rub that. Yeah. So your function is u of x comma y plus iv of x comma y, and z naught is x naught plus iy naught, w naught is u naught plus iv naught. Then limit of that function equal to w naught if and only if limit of u of xy is u naught and limit of v of xy is v naught. Okay. So start करें proof. Proof is quite simple. कोई भी form से start करो. That is from if you take that limit of this is w naught, and to prove this, that is quite simple. जो भी तुम लोग बोलो, कहाँ से start करें? तुम लोग तो बोलोगे ही नहीं. Let us take this one first and prove this limit exists. Okay, so if I am assuming this, that means what? If this limit is equal to u naught where x comma y and ये, ठीक है, that means what? Can you write the definition quickly? हम लोग करते हैं, ज़्यादा डिटेल में नहीं लिखेंगे. That's mean ये क्या है? Z, this is your x naught y naught z naught. So what will we be having? For given epsilon positive, there exists delta 1, and I'll write delta 2 also, satisfying whatever the condition, or let us combine both the thing, such that mod of u minus u naught that is less than epsilon by 2. Whenever you are having 0 is less than square root of x minus x naught. Since यहाँ पे coordinate दिया है तो I am not using z, otherwise I would have written z minus z naught that is less than delta 1. So x minus x naught the whole square, but next line में वही लिखेंगे plus y minus y naught the whole square that is less than delta 1. इसके लिए v के लिए क्या आएगा v minus v naught that is less than epsilon by 2. Whenever you are having 0 is less than, same thing, x minus x naught the whole square plus y minus y naught the whole square that is less than delta 2. Again you observe this is again a circle only. If you take, then you need to choose the minimum one, so choose it. Delta equal to minimum of delta 1 and delta 2. What should you start with? You will start जो भी प्रूफ करना है तुमको. प्रूफ क्या करना है, कंसीडर करो उसको. You need to prove f of z minus w naught. F of z minus w naught. So what is your f of z? U plus iv minus u naught plus iv naught. So this can be the, you can write it as this is less than equal to u minus u naught plus v minus v naught. I आएगा बट मॉड में आएगा कुछ फर्क नहीं पड़ता सिंस सेम रहेगा. Mod z is same as mod of iz. So this is your epsilon by 2, this is epsilon by 2, so that will be your epsilon. So your full limit of function is okay. We are done. Yes, whenever you are having mod z minus z naught that is less than delta, delta is minimum. So this part was quite easy. And how to start with the next one? Conversely, did you understand this one? That was quite easy. There exists delta 1 and delta 2. This is for delta 1, this for delta 2. Choose the minimum so that both should satisfy. So I'll start f of z minus, so मैंने थोड़ा cut short किया and directly we prove that. Yeah. Now conversely, start कैसे करना है तुमको? You are given with limit z tending to z naught f of z is equal to w naught. This is what you are given with. Correct? That means what? You are given with this. For all epsilon positive, there exists delta such that there is delta such that बोलो भाई, f of z minus w naught that is less than epsilon whenever your mod of z minus z naught that is less than delta. You just need to solve this much, just little bit. You can I write like this, u minus u naught that is less than equal to u minus u naught plus I times v minus v naught. I'm adding something, and this thing that is less, that is same as this one, so that is less than epsilon. We're done. Similarly, correct. And if you solve this और you तुम्हारा सर्कल वाला फॉर्म आ जाएगा, that is square root में वाला. And what about the next one? V minus v naught that is less than equal to u minus u naught plus I times v minus v naught that is again less than epsilon, which is from this one. Correct? So you have proved u minus u naught is less than epsilon whenever you are having this, but इसको थोड़ा तुमको वो फॉर्म में लिखना रहेगा. Alright, whenever, if you solve this, mod z क्या होता है? Square root of x minus x naught the whole square plus y minus y naught the whole square that is less than delta, since it is positive. Okay, hence proved. U minus u naught less than epsilon, that means what? limit u equal to u naught. V minus V naught is less than epsilon. That means limit V equal to V naught. Yeah, that's done. Yes, is that clear? Hmm. Okay, so let us go ahead to the next part, that is algebra of limit. I'll write it as theorem 2. Suppose you are having limit z tending to z naught, f of z equal to say w naught, and you can take any other limit z tending to z naught, say capital F of z बोलता हूँ मैं, and that is equal to w naught, capital W naught. So what is the question? Then prove the following. First one, their addition, their subtraction, that is limit z tending to z naught, f of z plus minus f of z bar, sorry, f of z, and that is equal to w naught plus minus w bar. What is the second one? You can do the scalar multiple part also. Similarly, limit z tending to z naught, say alpha into f of z, that is equal to alpha into w naught. Third, your alpha is your complex number here. Limit z tending to z naught. What is that? Product, no? F of z into f of z, that will be w naught into w naught. And what next? If w naught is non-zero, then you say for division also. Limit z tending to z naught, f of z upon f of z, that is equal to w naught upon w naught. Correct? Proof is same जैसे तुमने उसमें किया था in your first year and second year. Okay. क्या करना रहेगा? Whenever you are having to both the function, then you have to take the delta. You have to choose delta, which is minimum of them, and then you have to do. Correct? And just consideration part hai. I'll just give this as exercise to you. Prove this. This is fourth one. Proof is quite simple. If you have any doubt, then we can discuss later on. हाँ, प्रोडक्ट का कैसे करेंगे? How will you prove the product? You will see, इसमें अगर प्रोडक्ट निकाला दो कॉम्प्लेक्स नंबर का प्रोडक्ट, you will see it is again addition only, addition of two function. And you can use this theorem, that is usual, can prove the real part and imaginary part they exist, then you can say that limit exists. Yes. And also one more property, that is if you take limit z tending to z naught, p of z, where p of z is a polynomial of degree n, then this will be equal to p of z naught. That is quite easy to prove. You can prove that. Okay. Yeah. So now let us do the next part. Limits at infinity. That means what? Limit z tending to infinity रहेगा ये केस में. Something limit z tending to infinity f of z equal to w naught. Can you give me the definition now? Can you give me the definition of this? If you remember of sequences are same and tending to infinity. Yes, anyone? You can convert this if you don't die. Z tending to infinity. So what about 1 by z? That tends to 0, correct? So you can convert this of that form. So you can now give the definition of the limit. That is, for given epsilon positive, there exists delta satisfying mod of 1 by z that is less than delta. जिसको again you can convert this as mod z is less than 1 by delta. Sorry, greater than 1 by delta. Having the property that f of z minus w naught that is less than epsilon. Correct? The simplest definition is this one. Now graph में इसका meaning क्या है? Mod z is greater than 1 by delta. Yes, it is exterior of your circle, excluding the boundary. And what about this one? ये तो limit का हो गया. What about this one? If limit z tending to z naught is given f of z and that is equal to infinity, then what? Can you define this? How will you define this? Same thing. This is going to infinity, so 1 upon that will go to 0. That means 1 upon f of z, correct? Minus 0, that will be less than epsilon. So if you write this f of z, that is greater than 1 upon epsilon. So you are having the definition for everybody. Infinity हुआ या कुछ भी हुआ, correct? Yeah. So I have given you the definition. Using this, you have to prove this thing. If z naught and w naught are points in the z and w planes respectively, then prove the first one, that is if limit z tending to z naught f of z is equal to infinity if and only if limit z tending to z naught 1 upon f of z is 0. This is the first thing you need to prove. By definition follow होते हैं. Z tending to infinity f of z that is equal to w naught if and only if limit z tending to 0 f of 1 by z that is equal to w naught. Third, limit z tending to infinity f of z equal to infinity if and only if limit z tending to 0 1 upon f of 1 by z that is equal to 0. Yes, these three things you want to prove this. Now will you start with the first one? Write the definition of this. I already told you what is the definition of this. बाय डेफिनेशन फॉलो होते हैं ना. डू यू अंडरस्टैंड? Let us do the proof quickly. So what we are given with in the first one, limit z tending to z naught, f of z equal to infinity. Yes. So how did we define that? For all epsilon positive, there exists delta such that mod of z minus z naught, that is less than delta positive. And what is the condition? 1 upon f of z. Actually पहले तो वही लिखना चाहिए. F of z, since we are writing the definition, that is greater than 1 upon epsilon. So later on you can change this as 1 upon f of z, that is less than epsilon. Correct? Now if this thing is less than epsilon, I can write it as 1 upon f of z minus 0, that is less than epsilon, whenever mod of z minus z naught, that is less than delta. So you are having limit z tending to z naught 1 upon f of z, that is 0. This is what you are supposed to prove, correct? Look at the first one. Yes. And since it is, हर एक step देख लो whether it is if and only if. Can I go back? Done. Okay, this was the first one. What about the second one? Same thing. You need to just replace at the place of z, you need to replace at 1 by z. Can you do that? Write the definition. पहले definition कैसे लिखेंगे वो बोलो. Limit z tending to infinity f of z is equal to w naught. यही है ना? Yes. So how will you define this? Given epsilon positive, for all epsilon positive, what you have to do? There exists delta such that z tending to infinity. So how did we wrote that? 1 upon z, that is greater than epsilon, na? No, sorry, I wrote. Maybe 1 upon z is less than epsilon. That means what? Z is greater than 1 upon epsilon. This is what you should write here, since you are writing the definition. And mod of f of z minus w naught, that is less than epsilon. In the next step, what will you do? Same इसको ये लिखा 1 upon z, that is less than epsilon, and having the condition f of z minus w naught, that is less than epsilon. Now what? अभी प्रूफ क्या करना है वो देखो. You want to prove f of 1 by z ना, so replace z by 1 by z in the above equation. So you will be having f of 1 by z minus w naught, that is less than epsilon, whenever 1 by z क्या है, that is z, so that is z is less than epsilon. I should write delta here, हाँ. लोग बोलते भी नहीं हो. Correct. And what do you mean by that? That means limit z tending to 0, no? Z tending to 0, f of 1 by z, that is equal to w naught. Hence proved. It flows with the definition if you understand the definition properly. Correct? And similarly do the third one. When you do that in the third one, both of them is going towards infinity. So you know how to define that. Uh, if z tending to infinity, then you will be doing 1 by z tending to 0.